More often than not, new physics is uncovered when someone notices a discrepancy through observation. An example of this is in regards to the physics of Isaac Newton. For many years, his physics held up as, insofar as anyone knew, a perfectly accurate description of the universe that could be used to predict the behavior of objects in motion. But as time went on, discrepancies were noticed, and as they mounted, new theories by way of general relativity and quantum theory came in. Though not to really replace Newtonian mechanics, it's still well used, but to expand upon it to give a clearer picture of how the universe works. Another example is Albert Einstein and the expansion of the universe. He absolutely hated the idea, as did most scientists at the time, that the universe wasn't static and eternal, but had some sort of beginning. But as evidence, both theoretical and observational, mounted, it became clear that we live in an expanding universe, kicked off by the Big Bang, and the scientific consensus has revised itself. The result was a better description of the universe, with fewer discrepancies, that is widely accepted today. Yet, even with these new theories, there are still discrepancies popping up, such as situations like the subatomic world, where relativity breaks down and quantum theory takes over, or the conditions inside of a black hole, where the laws of physics as we know them stop predicting. One such discrepancy that has yet to be fully rectified is known as the missing baryon problem. Baryonic matter is what we see and are made of, the term covering protons and neutrons and everything made of them. Here we have a discrepancy between the amount of baryonic matter that can be seen shortly after the Big Bang versus what's seen in more recent periods. There are limits to the amount of baryonic matter that resulted from the Big Bang, however, known through studies of the cosmic microwave background radiation and studies of Big Bang nucleosynthesis. Big Bang nucleosynthesis is where, in the very early universe, basically the first few seconds to almost a half hour after the Big Bang, nuclei formed other than hydrogen. This is where the universe got its original helium, but also small amounts of deuterium and lithium. It's also thought that the radioactive tritium and beryllium-7 were formed, but then subsequently decayed into isotopes of helium and lithium. All other elements we see in the universe were subsequently created in the nuclear fires of stars. Given the state of affairs, Big Bang nucleosynthesis should have produced predictable ratios of helium and lithium versus hydrogen. This ultimately means that about 4 to 5% of the universe's energy content should be baryonic matter. This agrees with evidence from the CMB, where baryonic matter at the beginning of the universe has left an imprint. The numbers here agree, coming in at around 5%. So there are two pieces of solid evidence establishing how much baryonic matter was present in the early universe. But that's not what we see now, at least apparently. Somehow in the intervening time, a bunch of baryonic matter has just disappeared. This should not be. This is known as the missing baryon problem, and it should not be confused with dark matter, which is non-baryonic in nature so far as we know. More on that in a bit. This is approaching the point that half of the matter that the universe started with is simply missing today. Determining the density of baryonic matter in the universe today is tricky. Remember, it's all normal matter, so that can range from highly visible things like stars and galaxies, to hard to see things like rocky planets and the dust and gas clouds of the universe, to rogue brown dwarfs and objects plying the intergalactic medium and so on, to of course black holes, of which estimating how many of those are out there is a subject of much debate, especially if primordial black holes formed during the early universe exist or do not. But a decent estimate can still be derived from what we know. Several useful phenomena here are things like gravitational microlensing, where you can look at how much of that phenomenon you see overall, and clouds of gas and dust can be measured in several ways, such as if they are backlit, or emit radio as hydrogen clouds do, along with other techniques, enough to notice a large discrepancy, especially when looking at relatively recent galactic surveys. After all of this is accounted for, the universe is still missing on the order of 39% of its original baryonic matter. So where did the baryons go? There have been some proposed solutions. One was put forth in 2017, where very difficult to detect cool matter exists in the intergalactic space between galaxies that might account for it, or at least most of it. Further evidence from 2021 supports this, but it's not quite to the point of being case closed and needs more confirmation. This would mean that in addition to most of the matter of the universe being composed of invisible, non-interactive dark matter, a further huge portion of normal matter is nearly invisible due to circumstance, forming trailing tendrils through the depths of space between the galaxies. We live in a dark universe indeed. Only time will tell if this answers the missing baryon question, but herein lies another mystery, another discrepancy about matter in the universe. Where is all the antimatter? This mystery is known as the baryon asymmetry problem. Baryonic matter is normal matter, but antibaryonic matter is antimatter. By all rights, the Big Bang should have produced equal amounts of both, and in principle, all matter might have annihilated if it did. But that's not what we see, and both the standard model of particle physics and general relativity offer no insights on why the universe appears to have only produced normal matter, at least in large quantities during the Big Bang. There are many theories as to just why this is. The first is that somehow the laws of physics acted differently back then, or that some unknown factor played in, creating the asymmetry that we just don't fully understand yet. But there are other options. One idea is that the universe was only slightly off, and that enormous amounts of matter and antimatter were indeed produced in the Big Bang, but slightly more baryonic matter was produced. As a result, there would have been a huge annihilation event that left only a residue of normal matter left behind, which makes up the baryonic matter we see in the universe today. But there is another option, a rather spooky one. Perhaps the universe is made up of both matter and antimatter, and the two are just widely separated, concentrated in different areas of the universe. The strange thing here is that you could look at an antimatter galaxy from afar that has no normal matter within it, but it would be identical to a normal galaxy and look exactly the same. So long as the matter and antimatter components of the universe were kept apart and never came into contact, they could independently exist, and probably do so forever as the universe expands. But if two galaxies of different flavors were to come into contact somehow, the result would be the wholesale annihilation of both galaxies, leaving only a giant release of energy in a perfect reaction, and a residue of whatever form of matter happened to be from the more massive galaxy. But if this were the case, there should be some interaction in the intergalactic borderline between the two areas. Call it the matter zone and the antimatter zone. The borderland between should result in gamma radiation production from annihilating material deep in intergalactic space. No such radiation has ever been detected, and the general consensus these days is that antimatter galaxies probably do not exist. Another possibility is that conditions could exist that allow for matter and antimatter to decay at different rates, allowing for the asymmetry. But perhaps the most interesting idea regarding this is the idea of a mirror anti-universe. There are several takes on the concept of a two-sided universe, one with a normal universe and the other stretching backwards from the Big Bang as an anti-universe. One common theme is that the anti-universe would have reversed time. It grows in size the further back in time it goes, as a mirror to how the normal universe works. This concept has an interesting effect, in that it would actually explain the minute temperature fluctuations in the cosmic microwave background radiation, implying that the universe and the anti-universe may not be true mirror images of each other. Moreover, it might explain dark matter, in that such a paired universe would produce heavy neutrinos that could fit the bill, and also provide a source for very high energy cosmic rays. And it could also provide a home, so to speak, for the predicted antimatter product of the Big Bang. The antimatter is simply in the anti-universe, going backwards in time. This dovetails with some suggestions in the past that, in a way, antimatter behaves like normal matter going backwards in time, though that's somewhat of an oversimplification. It's an interesting thought exercise to imagine such a dualistic antimatter anti-universe, where it may mirror our own universe so closely that it might be possible for anti-humans on the other side to create small amounts of normal matter in their labs and marvel at how it annihilates on contact with antimatter. And of course, the greatest mystery of all facing astrophysics is dark matter itself, where you see the gravitational effects of an enormous amount of matter in the universe, but not the matter itself that's responsible for the effect. So far, an explanation or detection of dark matter has not been forthcoming. So this provides essentially three potential forms of matter that should be here, or once was here, but may no longer be, that we just simply don't see, which makes up the overwhelming vast majority of matter in the universe, both normal and otherwise. Or if you will, most of the universe is effectively missing. And it's conceivable we may never know what exactly it is, or where exactly everything went. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently adding in some more missing matter from the universe. The obvious one here are socks. Missing socks at this point may make up a percentage of dark matter, but there are also such things as missing cookies and missing donuts, for which there is no explanation as to where they went. Or at least that's what I tell Anna during health food audits over at Event Horizon. And when in doubt, blame the possum, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.